Hello everyone, my name is Ethan Page, and I am here to talk to you about some more concepts for programming in C# in Unity. In this video we'll be talking about JSON, loading data from JSON files in the resource folder, as well as other things, as well as loading data from the World Wide Web. We'll also be talking about namespaces and how they can interact with other classes, interfaces, how they interact with classes, and the properties of getters and setters within certain variables, once again, within these classes. Finally, we will leave off with some talk about object-oriented programming, a very useful tool for organizing and writing and such code. Now, to begin, here is the example in all of its glory. This won't make much sense to begin with, but bear with me as I will show it off and then explain it as we go. Now imagine this cube here. He's a player in a game, right? That is the avatar this player chose. This player's name is Jensen. He has a high score of 28,323 and a max HP of 100. He's doing pretty well for himself, I'd say. Now someone else decided they also wanted to be a cube, and their name was Adam. They had a slightly higher score of 28,493 and a slightly higher max HP at 105. Once again, the cubes continue, as we had Stark. 100 HP, 28,323. Pretty good score. Tony also wanted to play. He had a bit less score and a bit less health too. Once again, like the cube. Each of these cubes were assigned names, scores, and HP values. Now, whilst this may be fairly nested together, it is still readable. This format is the JSON format. JSON is a way of having readable data stored in text so as to not have to store everything within games themselves. You can then export this text, as that is all it is, to text files. You can have those saved, which are much smaller than many full-built Unity games. With that, if you have a few keywords, you can pull it back in, reinitialize it as data, and have the game continue, allowing for, well, the ability to save. As well as this, you can also pull things from the World Wide Web, allowing you to pull data such as textures, or in this case, raw text data, from the web to the game, or in this case, just the tutorial function. Now, if you heard my key being pressed earlier, there was a good few seconds between my pressing the key and it coming out looking like that. There may have been some formatting done on the web resource, as it seems a bit more vertical. Granted, that does make it a bit easier to read. After all, this has an ID of fish, a custom name doesn't have one, and there are 10 of them, which is a bit easier than having it all in one line back and forth, but in this case it does detract from the overall readability. That aside, it is more a proof of concept. You can pull things from online. To make that go away, let's put Jensen back up. Now, finally, we have the health of the cube. Let's say he started at 100, and as we scale him down, he's about to die. There he goes, he's dead. It doesn't seem like much, just distracting from a health value, but I'll explain how it uses both interfaces and getters and setters in just a moment. So to start off with, let's have a look at the code. Right off the top we have namespaces. As far as using statements, for namespaces, none are needed. The only extra ones I have beyond base are UI for displaying the information for the tutorial. It is not necessary for any of these things. The one that is using UnityEngine.networking. That is for pulling from the World Wide Web, as you may have guessed. Anyway, namespaces. You can define your own namespace and the data that is stored within it. For example, I have a public class in here called playerData within the namespace resource loading. This allows, once you've defined this namespace, it can be called from just about anywhere. It's treated as though it's static. There is one of it. There should only be this one of it. It can be pulled from, and you can set local variables to it. but it is the overarching resource, as it were. However, due to the way that is, it is more of a, for want of a better term, a global variable, a global class. It is a namespace. You can have more private versions for of classes of the same name. For example, just down here we have a standard class that is also called player data. It has max HP, high score, and name. Max HP and high score are slightly different to the above current HP and current score, but name is the same. I will get back to that in a moment. Aside from, or rather, namespaces allow for local classes and these namespace classes to have the same name, can even have some of the same data, but still be treated as different. The way they're accessed is through dot syntax, resource loading, dot play data. Same as you would many things in Unity. This can be useful for having overarching datas for certain enemies or certain players, certain characters in games, versus having to redefine them in every file, or set up their own variable, which would then have to be pulled from and cloned. This is quicker. Now, we also have interfaces. This is a public interface that I called iDamageable. Interfaces tend to do something, and the naming syntax is usually I for interface and then what it does. In this case, it allows something to take damage. As shown here, public class cube example, hence the little cube player that we had in the previous example, and it pulls from and implements iDamageable. This also uses the getters and setters I mentioned at the beginning. We have private data values of health and max health, and then we have a public float of health. The underscore is to help signify the difference between private while still having the same thing. Now when you want to use the health value and use it as a readable, it will summon the get part of this variable, which will just return the private value of health, in this case 100. If you want to set the health, well, then it will take the private health value, and this will clamp it so that it can't go above or below 0 or the max health value, and then it will also allow, if it is changed from anywhere, then if the private health value ever becomes less than 0, then it will destroy the above game object, the test cube. This is so that these private values are not directly accessed if they don't need to be, which is one of the forms of, one of the parts of object-oriented programming. My apologies. Specifically, encapsulation, but I'll get more on that a little bit later. Finally, when we created when we implemented the iDamageable interface that has this function, we essentially made a promise that we would actually use this function in this class. That is exactly what we did right here. We put the function in. All it does is it takes the public health value and subtracts the float damage amount from it. It just deals damage to the cube. And that is what allowed, in the Unity example here, once it loads, as it loves to take time, for the health to go to 90, 80, 70, 60, 50, 40, 30, 20, 10, and as we saw here, if health becomes less than or equal to 0, it destroys the cube. Now, you may be wondering, you didn't see me call the take damage function. It happens a little bit lower. In fact, right down about here. This is another function, public void take damage. This is something that can be called by just about anyone. All it requires is an iDamageable object to be passed in this case, the above test cube. the damageable object, you then call the take damage function from within this. This function allows for just about anything to call certain functions of, well, certain interfaced objects. It allows for more things to do more without having to directly implement a lot of these classes and functions. I will get to this in a moment. This is the direct if statement that deals damage to the cube. It updates the screen text with the health values, does it twice just for a before and after, and it simply calls the below take damage function with the test cube as the passed in damageable object. Now, to show the JSON script, we have this little section of code right here, JSON files. When I press J, it takes the save data of max HP, the high score, the name, and it sets them equal to the variables that I created up here. It then will take the player save JSON that was also created right about here as a string, and will set those values into string format, and will then write it in that string format, well, or rather, my apologies, to say that better. The string is then set equal to the player class that has been implemented and had the data set to JSON format. Which is why, when I press the J key, it comes out looking like this. Now we also have the resources folder, which has 2 JSON files in it. If I were to open this file in MonoDevelop over here, it shows exactly what I just wrote. It is Adam. And that is the second part of this, pulling data from the file. It makes playsave.json, which is what's being shown on the screen, equal to the JSON file versus the data that I had here. That is also what is done when I press R. It does it a slightly different way, however. This pulls from the namespace class, just to show there's a difference, and will pull and write to the resources folder via resource loading. Specifically, right here is where resource loading begins. The second JSON file, as I called it JSON file 2 because I'm creative, resources.load a text asset file, as that is all it is, and then the file path. The file path in this case being, if I open that and find references, thank you, let's show that one, or that one. File path being local JSON2, that is the second JSON file. So it takes that file path and sets this in-game text asset file to the contents of that file. Play save resource loading then equals the JSON file.text and will then overwrite the data that's in there with the resource that I have written from the save data resource. For example, once again I have it here, if I hit R, well now we're seeing this. If I open this, the data is different. That is because when I then hit R again, it's pulling from this once more. This can be written to, it is overwritten, all these things. But by default, this is what it has. I just showed it so that to prove that you can pull data from these files as well. Let's close off these. Finally, we have the web resource. I have a coroutine started here that gets the data when I hit W. Now get data is simply starts a new web request. This is where the using networking statement above at the top comes in handy. Just www. www equals unique web request.get, and then you enter the URL of the place you're trying to pull the data from. In this case, I have a PHP file with player data from this URL here. You'll return www.send. We'll send it back, and then I have it spit it up onto the screen with the screen text web resource. And that just shows the text, which allows for this horrible mess of that to appear. Of course, in a game, you are less likely to just pull this and put it onto the screen. It is more meant for the saving of data and the ability to not have it take up too much space in the middle of things. Now, as you can see here, a lot of this, it seems fairly messy. This isn't very well object-oriented, per se. It's not very well encapsulated, aside from this little bit here. There isn't much to do with abstractions or inheritance or polymorphism. The closest to inheritance we get is implementation of an interface. It's close, but it's not quite there. So, that is where this second project comes in, as I like to call it, the cube. As this closes. Now, this is the object-oriented one. It's not much to look at right off the bat there. Again, fairly bland, as most of these seem to be. However, the console is what we're going to be looking at mostly here for the rest of this tutorial, as that was where the rest of this begins. No special using statements, just off the bat. We have interfaces idamageable again, except this time we're going to have two classes. The weighted test cube that implements idamageable. It has a color, health values, once again has the getters and setters, because that is good for encapsulation. It has a color of gray. Its hello statement is just a ... It's not very friendly. And a neutral goodbye as its death message. It also has the take damage function as per the idamageable. Now we have a similar class that inherits from the above weighted test cube. This is the beginning of inheritance and also polymorphism. Once again, it has a health value, max health value, public health value with getters and setters. Once again, good encapsulation. Encapsulation being you don't need to show things that aren't necessary to be shown. For example, you don't need to make every single variable public. The other one that needs to be is this health value, and even then it interacts with the privatized health values. And max health never needs to be changed, so it will only ever be private, only ever accessed by this class. Now, to continue on, this cube has a cube color itself. It's a light grey with a pink heart. It has its own hello message, a little more friendly this time, asking how it can be assistance. And a death message that is a bit sadder. Now, since this implements from the weighted test cube, or inherits rather from the weighted test cube, that implements the idamageable, it also has to have the take damage function. So it does. Finally, you may have also noticed, instead of just having public voids, we have public new voids. This is for overriding and specifically for polymorphism. This is so that when the weighted companion cube calls hello, it calls this hello message, the friendly one, instead of the slightly colder, more ... Finally, I have my control integers just for the sake of the function doing what it does. And this is where inheritance and polymorphism begin just a little bit more. I create a weighted test cube of dull cube, that is a new weighted test cube. Now I do the same with the companion cube, called the emotional support cube. That is a new weighted companion cube. I'll get back to polymorphism in a moment. Now when I press T for the test cube, it will spit out the color, do the hello message, and its health. When I press it again, it will take damage. When damage has been taken in the classes, if health gets to below or equal 0, it should display the death message specific to the class. For this class, of course, the neutral goodbye. For the companion cube, No. To show this, let's press T. Once it loads. There we go. It spits out, it is grey, and it's got the neutral hello message and 10. And then it says goodbye, because its health has reached 0. Now, if we clear this and go back, and we have a look at C for companion cube, it will spit out its own colour, its own hello message, and its health. Now, if it takes damage, it will run the take damage of the companion cube. However, due to these take damage, or rather not the take damage, due to the death message being within this health value, which is public and the same between both of these classes, there is no difference between them, it will in fact display the death message of the test cube instead of the companion cube. You can still access the death message of the companion cube, you just have to call it a bit more directly. For the getters and setters, it does have that slight bug. Just a word of warning. To show this, over here, if I press C, hey, light grey pink heart, hello, has health value of 10. But look at that, goodbye. Just to show that it can in fact do it the right way, I do have a third thing happen when you press C. Again, it will in fact display the death message of the emotional support cube. And this is all still inheritance, pulling the same files and functions. And there we go. No. Finally, we have what happens when I press P for polymorphism. This is where this line comes in handy. I create a dull cube in disguise of the weighted test cube variety that is of type weighted companion cube. This works because the companion cube inherits and from the test cube. This is a parent to this. Now, dull cube in disguise dot hello. This will call the hello function and the cube colors of the companion cube. Let's see. If I press P, well, it pulls the color, but it pulls the hello message instead. The interesting thing with polymorphism is due to the hello message and the type of object it was implemented as, after all, it was a weighted test cube. It pulled the color from the weighted companion cube, but it pulled the hello from the weighted test cube. If we continue and I hit P again, now undisguised cube, it has revealed itself. It is weighted companion cube type dull cube in disguise. It takes this object and then instead makes it of this type, overriding it. It'll then display the hello message again and the color. Well, the color is the same after all, it's still a companion cube, just it was in disguise. And now that's revealed its true colors, it actually has its proper hello statement. Now that is the... I suppose in conclusion, I should say, polymorphism is the ability to overload and override. That is where all of this comes in. It is overloading and overriding the weighted companion cube types into the test cube types into the companion cube types in this example. It allows for abstract classes and various abstractions to be created and then implemented so they can be overridden by child classes that have similar things done but with slight differences. This means you don't have to rewrite everything. Inheritance means that children objects can pull from parent objects, hence the death message. Encapsulation is the separation of data from what needs to access it. So if it doesn't need to be accessed by the public, it won't be public. It's quite that simple. And abstraction is the ability to have a base class that is then utilized in things like polymorphism to be overwritten so that it can... you don't have to write it over and over and over again. That is the basics of not polymorphism, of object-oriented programming, as was hopefully conveyed in this rather simple project. Overly simple, in fact. Still, this was just meant to be a demonstration, and as such, thank you for watching.